Say hello, hello.
Hi.
If you don't know who we are, I'm Duca.
I'm Roberta.
And this is Ollie, and we are building this beautiful 43-foot deck saloon aluminum sailboat. And on our last episode, we talked about the second means of propulsion of our boat, the engine. Because the first one is the sail, of course. Yeah, so sail first, engine second. Anyone that lived on a heavy boat before, you know that when you need to maneuver the boat in tight spaces, it's always a tricky situation. And when you have wind blowing sideways, it can get even worse. So that means on this boat, we decide to have a bow thruster. Yeah, so on this boat we decide to have a bow thruster, and we're going to show you exactly the bow thruster we're going to use. We're going to start installing the pipe of the tunnel of the bow thruster, and we're going to talk about why we chose this specific bow thruster and why we even decide to have a bow thruster. So let's get started. I just received some good news. There is a pack in front for me. They just delivered to Robin, and it's a pallet. So that means if it's a pallet, it's something big, and I'm hoping it's something that I've been waiting for a while to have, and it's gonna be so good for the boat. But before I jinx it, let's see first. This is our new bow thruster, and it's massive. First of all, having a bow thruster, just having a bow thruster is a dream coming true. On our last boat, maneuvering the boat was just always a nightmare. The truth is, many cruisers are gonna pretend they're not scared to maneuver a boat, but the truth is when you live on a boat, you rarely go into marinas, and that means if you maneuver less, you know less how to maneuver, because when you just sail on the weekends, you go in and out the marina all the time, every weekend or every other weekend. But when you live on an anchor, that means you almost never maneuver. And when you go maneuver, it's always complicated because you're not used to do it anymore. And sometimes you spend like 6 months, a year without maneuvering in a tight spot. And that's really complicated when you actually need to maneuver in a tight spot. And of course, every now and then you need to go to get fuel, or you need to leave the boat somewhere. And you do need to maneuver in tight spots. And having a bow thruster is just gonna be a game changer. It's gonna change everything. On our old boat, maneuvering was really complicated because we had no keel. We just slide sideways. So if the wind was blowing sideways, the boat would just drift sideways really badly. And on this one, the challenge is a little bit different. We are gonna have twin rudders. And with twin rudders, there is no reverse control at all. We don't have the third rudder behind the propeller. That's a possibility. Our friend's boat has a third rudder right behind the propeller to help on that. We don't, and the reason for that is because we wanted to simplify things, but there is a trade-off. It's harder to maneuver going back reverse, but having a massive bow thruster is going to help a lot. First of all, this is a Sleipner E150. That's a 150 kilograms force bow thruster. Yeah, that's massive, but there's a reason for that. Our boat has a really high freeboard, and of course we are not deciding that by ourselves, we are deciding that with Sleipner, so we are working together to create the perfect system, and they run the calculations on their software using all the information from our boat and all the drawings from our boat, and that's what they came up with the ideal solution. And their words were, if you want to work together towards a perfect system, we want to go with a little bit extra power, because that's when you actually need the bow thruster, when you have 30 knots of wind. When you have no wind, you can manage to maneuver without a bow thruster, and that means when there is 30 knots of wind, if you go smaller, it's not going to be enough, and that's when you need it. So it doesn't make sense to us that you use that. And of course, there are trade-offs. For me, the biggest trade-off is the size of the tunnel. So this is 220 millimeters internal diameter. If we go a little bit smaller, we would have 185. That means 35 millimeters is smaller, and that's around 1.5 inch less diameter. That of course, it's less drag, yes, but also it means a lot more power when you have a bigger diameter, so it's a trade-off. You want a bow thruster that when you need it works properly, or you want a bow thruster that you can only use until a certain amount of wind, or you want no drag at all. If you want no drag at all, you just don't have a bow thruster. First of all, there is always going to be a tiny little bit of drag, but I think it's a good trade-off because this is going to help us so much in really complicated situations that I think is totally worth. And also it makes it a lot easier for us to maneuver single-handed if I need it. For example, now we have a baby, we have a kid, and if Roberta needs to take care of Ollie and I need to dock by myself, it's much easier with the bow thruster. And there are a few other things that we need to make decisions before we decide which bow thruster to use. So, for example, there are mainly two different kinds of bow thrusters. The tunnel one, so that means you have a tunnel on the bow of the boat, crossing the boat, and the bow thruster is fixed on the tunnel. Or you have a retractable one, that means you have no tunnel, but when you want to use the bow thruster, it needs to go down, you use it, and then you need to lift it back up. Our decision towards the pipe one, the tunnel one, is because it feels a lot more simple. There is a lot less moving parts, and that makes easier to maintain, in my opinion. Of course, some boats it's not possible to have a tunnel one because it's too shallow, the bow of the boat, and it's not possible to install a tunnel. Then you need to go with a retractable one, but I rather use a fixed one than a retractable one. And also, it's a much smaller hole on the boat for failing and ingress of water. When you have a retractable one, it's a massive hole that you need to have on the boat. And I don't know, it works, of course, a lot of people have them, but I prefer, in my humble opinion, I prefer the fixed one, and the hole is pretty tiny. It's just these 3 little holes, and that's it. That's all the holes you have on the boat, so that's really good in my opinion. And now, why did we choose Sleipner? I mean, Sleipner is a company that's been around for over 100 years making motors, and that's huge. They have a lot of technology and a lot of knowledge about what they build. So we decided to go with someone that we trust, that know what they're doing. And also because we have an aluminum boat, and some of the manufacturers of bow thrusters, they don't have a ready to be installed on an aluminum boat bow thruster. What I mean by that, it needs to be electrical isolated in order not to have a straight current and have trouble with the aluminum hull. So Sleipner has a kit that's a really simple thing, but at the same time a really important one. That's a tiny little isolation kit, and with that we electrical isolate the bow thruster from the hull of the boat, and that it can literally save the boat. So that's one of the big reasons we wanted to have a Sleipner bow thruster, is because we want the isolation kit. I really like their twin system propellers. So this is like the sail drive of a bow thruster, and you have one propeller on this side and another one on this side, and that means you have a lot more force with the same motor. I actually just realized that some of you might don't even know what's a bow thruster. A shame on me, I should explain that before I show everything. So pretty much a boat has an engine that pushes you forward and backwards. That's what an engine does. A bow thruster is a different mean of propulsion on the opposite direction, 90 degrees of that. That means it pushes the boat side to side, not the entire boat, just part of the boat. So a bow thruster is an engine, or a motor, electrical motor, that's an electrical motor that goes on the bow of the boat. So that means it has the power of pushing the bow of the boat to starboard side or to port side. You could also have a stern thruster, that means another thruster on the back of the boat, and with that you could just literally turn around, just push one this way, the other one that way, and just turn around the boat. Or you can even just go sideways to the dock, just like imagine the dream car that you can just parallel park sideways. That's pretty much what a bow thruster and a stern thruster together do to the boat. We don't have space for the stern thruster, and I don't think we need, to be honest, because we can use the engine and the rudder as a stern thruster and then the bow thruster just to help. And I think that will be enough in our case. Our boat's not that big, but if you had a stern thruster and a bow thruster, you could have a joystick just like this one, but with two leverage. So this one is just to control if I go to port on the bow or to starboard. You could have two, and you could just twist the boat, like literally turn the boat around and park sideways, and that's really impressive. So how do you install this massive motor on the boat, on the tunnel of the boat? So this is the support, This is the tunnel. So imagine that you have this installed on the bow of the boat, and then this support will go sit on the top of it. So sit on the top of it, and this motor will sit on the top of the support, and then the shaft will go from the inside and connect to the hull. That's pretty much it. You tie it all together and you're good to go. It's not that simple, of course, there's a lot of work to install, but that's the installation. So that's what this is. And also with this support, we can install lower than 45 or 30 degrees, because you don't need to install this standing up. It can have an angle, and if you want to go lower than a certain angle, you need a support from the bottom. So that's what this is. In our case, we're going to have an angle because in order to have the correct height of the bed on the bow, we want to have the bow thruster in an angle, because this is going to be installed under the bow cabin bed, and with the support it's going to make life a lot easier. It also came with this massive switch and fuse. This is just so minor. I never seen something that big. It's just so well built. So this is just a safe measurement. You need to have a big switch and fuse, and it comes with the kit. It also comes with all the electronic cables. So these cables are going to connect the control to the switch, to the unit, to everything together. So tons of different cables. So one more thing I really like about this bow thruster is that it's variable speed, because some bow thruster you just press on and off, and that means when it's on it's fully on, when it's off it's fully off. This is variable speed, so that means you can control how much power you use, and that's, for me, it's much better for maneuvering the boat when you have variable speed, and that's really cool. Another really cool thing about this propeller that they call keel prop, because of the shape and the geometry, it reduces 20 to 40% the noise of the bow thruster. Some bow thrusters can be really, really loud. It seems like nothing, but for us it's annoying because we record videos all the time, and you're speaking and suddenly like the noise is really loud and gets really confusing for who is watching the video. So for us it's really good. And also another thing that reduces the noise of the propeller is not having air, not just noise and efficiency of the bow thruster, is if you have any air coming into the tunnel, and to ensure that you need to have a certain depth of the tunnel to guarantee that no air can go through the tunnel, and that makes the noise a lot better. And also the edge of the tunnel needs to be more round. If it's too sharp, it's going to have a lot of turbulence, and then it's just not efficient at all. So that's the tricky thing that we're going to do on this episode, because you might ask, why do you have a bow thruster right now? The boat's not even close from ready. The truth is, we are getting to a stage of the build that we need to know the equipment you're going to use in order to have the aluminum welds done, and we need to install the pipe. So now that you know everything about our bow thruster, it's time to go open a huge, massive hole on the sides of our boat. That's really scary. Even though it might seem normal to some people, opening a 240 millimeters diameter hole, it's even more because it's on an angle, so it's bigger than that even. It's just, there's no way back. Once you open the hole, you need to have a bow thruster, and it's going to be awesome. So let's get started. So it's weekend. On weekends, Peter doesn't work, so my helper, Kobe's here. He's back. Kobe's back. He was on vacation. He was sailing. That's why he didn't come the last few weekends, but he's back. So today we're going to do one mark that's really, really important, that is the bow thruster tunnel. So here we're going to have the bow thruster, and we need to mark the tunnel, and that's scary because once you mark, there is no way back, because you're not going to measure, and you're going to just accept that that's right. So today we're going to accept the position of the bow thruster, and that's pretty scary. So as you can see, we have the waterline, and that's what we need, because we need to measure the position of the bow thruster based on the waterline. The internal diameter of the bow thruster tunnel is 22 centimeters, and the specification is that we need to have the internal top side of the diameter one diameter at least from the waterline. Ideally would be even more, but on this boat it's just going to be impossible because the bow is really shallow. So we're going to do one diameter below the waterline, measured by the top of the tunnel. So this is the external diameter of the pipe that we're going to install, and with the ruler I can know exactly how many centimeters below the waterline we are. So right now we are 21.5, and that's exactly what we need. And the idea is that we're going to locate that in a way that we can weld the pipe. If, let's suppose, the pipe ends up here, there is no way Peter can weld when it comes to this little corner here. It's going to be impossible to weld. And if it's too close from the bottom of the boat, also he's not going to be able to weld the bottom side of the pipe on the ends. So it's a balance in between the right height according to the waterline, but also the right height that he can reach the weld. So with this we know the height, but we need to know the distance from here because it needs to be parallel to the frame. This X marks the center of the hole for the bow thruster tunnel, but I cannot see on the other side because of this, so I'm hoping if I take this one out temporarily, I can mark on the other side, and then I can do some measurements to double check if that's on the same position. According to my laser, I have a parallel line to the bow, to the frame, and if that's true, that line is going to be on the same position. Of course I did a mistake. The guide hole that I did, instead of being parallel to the water line, is perpendicular to the plate, and the plate is 45 degrees to the water line, and that means that's not going to work. At least I just drill a really thin pilot hole. I'm going to do a thicker one now, and I'm going to try to fix this angle, but to guarantee that I'm parallel to the water line, I'm going to put the laser level so I can use that as a reference for the drill. Turn off the light. Time for the truth. Let's see if my guide bar is gonna go through the hole. So the hole is right there. Good news, it fits. Now I just need to make sure it's aligned both sides. Not long enough. Probably was just seeing the reflection there, but not on the back. So that means I need to probably just go down more with this hole. I think that's a wing. I don't know if you can properly see because it's really dark here. When you work with the laser, it's better to be dark than bright, but the guide bar is in place. I just put the laser level, like the little bevel box with the angle, and the angle is like 0.15 degrees. That's more than enough, way more than enough. And also we already have a little block on the center. The idea now is that on this block we're going to create a little arm with a support for a marker, and then I can slide the support around the fixed bar and we can draw the shape on the plate. After that I can just go and drill around the hole, and we can go from there, making progress. This is going to be awesome. I cannot wait to have this pipe in place. That's a huge project.
Because Francis was telling.
Good news, as you can tell, we have a shape. I don't know if you see the little dots. If I just connect these dots, I have a shape, even though it looks like weird because it's like it's not even an ellipse, it's like a twisted ellipse. And the reason for that is because this plate is 45 degrees to the vertical plane, and also it's crooked. It's closer here and farther here, so that means the ellipse is not even a perfect ellipse, it's like all twisted, but that's the way it should be. It's a little bit smaller than that. I needed to change the pen, the marker that I use, and then I calculated already, and it gives me an extra 3 millimeters. So I'm gonna draw a line around this circle, and then I'm gonna do another offset line to the inside with another 3 millimeters, and that's supposedly the place where we need to cut. But before we do that, I still need to mark that side, and I still need to mark here, because we also need to cut this, stiffener. And after that, Peter is gonna weld some reinforcements to the plate, because we are afraid that if we cut the plate here, it might have internal tension and bend. I don't believe it will happen, because it's really reinforced everywhere, and it's really flat also. That's not a curved plate, so I don't think it's gonna bend. But you know, we say in Brazil that the insurance is dead because it's old. I don't know how to translate that properly, but there is a saying that you need to make sure you, I don't know, just do it safely, and we're gonna do it safely just to guarantee. And hopefully by today, the end of the day, we're gonna have 2 huge holes on our boat, and that's scary. But sometimes you gotta do what you gotta do, and that project needs to get done. We've been trying to do this for a while now, and now we have the pipe, we have everything we need. We just need to create the hole, put the pipe and weld in place, and then we can saw the bow thruster, and then we can do the rest. But that's the most important right now, is to finish the structural part. So I did a template with this paper from this drawing, just to make sure we have the same drawing on both sides, because a jig, you never know if it moves a little bit and then the shape is completely different. The shape is exactly the same, that's first good news, but the hole is not precisely on the same distance from the frame and the same distance from the bottom of the boat. So that means if we do the hole as it is, it's gonna be a little bit crooked. So our idea is, we do the hole on the one that we like the most, the position, we slide the pipe, we get the laser level, and we level the pipe, and then with the pipe we mark the center, and then we mark that one. So we start with a starboard side, and Peter already welded some braces around just to make sure that this plate doesn't move once we create the hole. I don't believe it will, because it's really flat, the plate, so I don't think there is any tension pulling or pushing the plate in a different direction, but you never know, just to be safe. Now we're just gonna cut this hole, then we start sliding the pipe, and that's pretty scary because it's a huge hole, and it's gonna be a really tight spot to weld actually. It's really complicated with this frame. Peter is gonna have a really hard time finding the right angle for the gun, and it needs to be 100% watertight. But sometimes you gotta do what you gotta do, and we're gonna just open the hole and find a way of doing it. Scary moment. It seems like I'm just like pretending to be scary, but no, it's actually really tricky. That's probably the trickiest project so far on the journey, but we'll get there eventually. Slow progress, but I'm making progress at least. All these small holes are done. Now I'm just enlarging the holes to connect them and to open that. The reason we are doing this way is to be more control with the angle grinder. It's going to be really hard to get the right angle because this plate is 45 degrees, it's not 90 degrees like the other one. So it's going to be easier to just drill like that, and then we just grind off to the right shape. But I've been breaking a few of the drills. This one was literally on the first 2 seconds of using it, just broken in half. Let's go outside and check how it's outside. It's a huge hole. The thing is, I've been learning a lot about bow thrusters. I didn't know about that before. The most important thing is to be really low, because if there's any air on the bow thruster, it just efficiency just goes down a lot, and that means we need to go down, or you need to go a lot back. We went a little bit back already. A lot of people are going to say, oh, you're too back that way, but it is what it is. We cannot go deep enough if we don't go a little bit back. And also, of course, we are doing all of this talking to the manufacturer, talk to Sleipner. they are the ones that said no problem, it's not going to make any difference if we go a little bit back, because the pivot point, I always thought it was the mast, and in reality the pivot point is the watertight, pretty much, it's like a little bit before even the watertight bulkhead on the entry of the boat, and that means 20 centimeters, 30 centimeters is not going to make enough difference. What's going to make a difference if it's not low enough, and also if you have sharp edges in between the pipe and the plate of the boat, it makes a huge difference in efficiency. So we want to have in a position that we can properly build up weld, so we can grind and we can have a round edge, because this changes a lot also the efficiency. Get in there. Yeah, that's a project that I've been excited about for a while already. The pipe's been sitting there for a little while, but of course we have a lot of other things to do, but the time came. Let's do this. Just went for lunch really quick at home and play, of course, with Ollie a little bit. And when I arrived back, check this out, we have a huge hole on our boat. I'm not really sure how it's gonna be the clearance to slide the pipe here. We don't have too much space. I don't know if you can see, but there's this wall there. I hope it's enough space, otherwise we might need to cut the pipe a little bit shorter, I guess. I mean, Peter is not here right now. Probably he went to the factory to do that, I would guess. Let's see if the pipe is still in the workshop, because the pipe was there. Give me 1 second. I don't know if we have a pipe here or not. Yep, I was right. The pipe was right there. So that means he's in the factory cutting the pipe. Let's go there and see what he's doing. So if you don't know what I mean by going to the factory, by now you probably know that we live inside a factory. We are building the boat inside one of our partners' factory. This is Welding, so all this space is a factory from Welding. They build woodwork machinery, the ones we have on our shop. I just want to take a second to thank them. Without them, we would be in huge trouble this year, and they saved us when we needed, and they are awesome people. So if you ever want to buy a panel saw, a table saw, a thickener, a planer, anything like that, you just go to the website welding.com. Yeah, they just produce really beautiful machines, and I would love you to know them if you don't know them, because they are just our savers. They just save us really badly, I mean really goodly. Yeah, they're just overall really good people, and they build really beautiful machines, and these machines are built on this factory. Everything, every single part of the machine is built in-house, and that's exactly where we are. And Peter works for them actually, and here's where Peter cut the metals for the machines, because on the factory he's not a welder, he cuts material, and right now I guess he's cutting our pipe. As I imagine, it's much easier to cut a pipe this big with these dimensions with a proper machine, otherwise the cut's never going to be straight. That's huge, by the way. Check this out. Awesome. Peter is just going to cut a slice of the pipe. In this way we don't need to carry such a heavy pipe in order to put in and then test and cut and test and cut and test and cut, because right now there is still a lot of grinding on the cut to do, and it's really hard to do that if you have a huge pipe. You need to hold a 2-meter long pipe that's really heavy. That's going to make life a lot easier, and we have more pipe than we need, so it's no problem. This is a tiny piece and it's heavy already. It's really, really thick. So now let's hope we did a good job drawing that. To a point that fits. I would go like this much.
The laser.
By the way, that's the thickness of our plate on the sides under the waterline. On the bottom is even thicker. That's heavy. That's really, really thick. 1 centimeter thick. time for the truth. Let's try to slide the pipe in place and see how close we are. I think it's close enough, to be honest. How parallel are we from the frame?
A half centimeter in each direction.
From inside the pipe I can see the other side. I don't know if you can see there.
It's really...
We are really close from perfect. That's awesome. The hole is actually right. It's just the angle of the cut on the top that needs to be flat, because right now has an angle like this. If he flats with the waterline, then the pipe goes down and then it's straight with the waterline. Right now we have 3 degrees of angle, and that's almost nothing, so you get there. Now I'm more relaxed. It's gonna work. I mean, it's still tricky to weld, but first step is get the hole right. I think we nailed it. Can you put the flashlight on the back? Just put your light around the pipe.
Yeah.
I think that's it. We're gonna do that like 10 times, I think. So it's this, this, and this. So I bring good news. We have everything right. If we put the laser, the level, .10 degrees, absolute nothing, that's perfect. And we also measure the bottom of the tunnel to the bottom of the plate on both sides, and it matches. So now all we need to do is to make sure we mark the final line of this side using now the tunnel as a reference, and then we can cut this side, do the same thing, trim until it slides, then we can mark the pipe and cut the pipe to the angle. So Peter just welded a little bracket just to hold the pipe without moving. Now we can take the clamp out and then we can properly mark and keep going. We're really close. The problem is that every time we go a little bit forward in order to get the right shape of the cut, of course it gets tighter and harder to put in and out, and now of course we got stuck. It won't move. I've been hammering but it won't move. Let's see if we can take this out. So, let's take it out. Yep. Now Peter needs to grind a little bit more this side, and I think we're good to go. Yeah, it's just a matter of grinding, take it out, in, out, grind. There's a lot of wiggling and trying to adjust to make sure we have a straight tunnel for the bow thruster. That's great news. The tunnel came through. So now that the tunnel is in position, we need to do the final alignment inside to make sure we mark the cut right, because now we need to mark this pipe where it touches the side of the boat, and then we're gonna cut the angle on the pipe. But in order to do that, we need to make sure that the pipe is horizontal with the water line. And and the pipe needs to be 90 degrees to the center line of the boat. And if these two conditions are met, then that means the pipe is straight and we can tack in place. We're just gonna tack weld to this reinforcement, and then we go outside and we mark the cut, take the pipe out, cut, and weld in place. Yeah, that's 0.1 degree, that's perfect. So now I just put a laser level on the pipe, so I know that we are measuring from the same place, and I measure the distance from this line to the diesel tank with another laser level, a laser measurement device, and we got to 1 millimeter difference, and 1 millimeter is, I mean, like my hand cannot even be precise as 1 millimeter, so it's 100% fine. So the next step is just to mark the cut on the ends of the pipe. Then we can take the pipe out, cut the pipe, put in place. We need to clean, of course, everything really well, because that needs to be a watertight, a really important weld that's under the water line, so it needs to be properly clean. Let's close that. Now that we have all the marks, it's pretty much following this shape on both sides, connecting number 2 to number 2, number 1 to number 1, X on the top, and we're good to round. Peter believes he's gonna cut in between the inside and the outside line, because this thickness is the thickness of the hull. Yeah, that's a really thick hull. So if he cuts the outside line, that means he will need to do too much grinding later. So his idea is to cut somewhere in between, and that's going to be a pretty tricky cut, but he can do it. That's it. It seems like from the video probably it's a simple job. That's not simple at all. That takes a long time to cut this thick. Oh, look at this. It's really, really thick, and the problem is that you also have an angle, so it's really hard to get the disc on the right angle because of the curve. The other side. Yep. Here is good. It's a matter of alignment and twisting. I think that's it. I'm so excited. Yeah, our last boat, we didn't have a bow thruster, but the boat freeboard was a lot lower. And even though the freeboard was a lot lower, many times we wish we had one when you're gonna get a mooring and then suddenly the wind just blows you sideways and you miss the mooring. You need to go all the way around and, you know, do another maneuver, or in your docking. For this boat, the freeboard is literally twice as high as odd. So that means we're gonna have a lot of more windage. And with the bow thruster, that is going to be a overpowered one, because of course the company that produces the bow thruster is Sleipner. they run the calculations through their software and they decide the size that can handle any situation pretty much. So we're gonna have a strong enough that if you're, I don't know, mooring the boat, we can always just fix the bow instead of going all the way around. That's pretty awesome. And also it's gonna make maneuvering a lot easier, because on the old boat on Odd we just had one rudder. Here we're gonna have two rudders, and two rudders with one engine in the center without a third rudder behind the propeller. That means on reverse you have no steering at all. That's just the way it is. Compromise. So now the pipe is in the right shape. Peter already grinded flush the end of the pipe on both sides. That means the pipe is flush with the outside of the side plates, but he needs to have a chamfer in order for the weld to penetrate deeply, because it's a really thick plate. If there is no chamfer, he's not going to get full penetration, and we need full penetration because of the water tightness. So the idea now is that he's going to slide the pipe a little bit to one side, like 3 millimeters or so, or a little bit more even, grind flush again, and then slide to the other side and do the same to the other side. And when he centers the pipe is going to be a little bit shorter than it is right now, and that means he's going to have the space for the weld on both sides. I think it makes sense, and in this way he can have a really deep penetration and full penetrate the material and have a strong weld, because it needs to be watertight. That's the idea. So just to understand what I mean, right now the angle is right, but it's a little bit too deep, the pipe, and the reason for that is because he just slided the pipe a little bit that way, and now he can grind the other side flush with the plate, and when he slides back he's going to have half of this distance here and half of this distance on the other side, and then there is enough space for the penetration of the weld, so he can weld in between, inside and outside. This is sticking out, so now he just grind this flush, divide the gap, and that's it. So now Peter is happy with the distance we have for the weld. He just wants to add a little bit of a chamfer on the outside of the plate and the inside of the pipe, not all the way through the material, just on the beginning, because the first pass of weld he don't want to have a chamfer, because we already have a little gap, so that's enough. It's going to penetrate well. But on the second pass he wants to have a chamfer so he can have a wider weld. As soon as we start welding, it goes fast. It's just the preparation takes a long time in order to guarantee that it is right. As you can tell, we didn't manage to weld the tunnel in place yet. Yeah, there is a reason for that. The reason for that is because Peter, our welder, said he was not comfortable of doing by himself, because he's not a boat builder. He's a welder, but he never built a boat before, and this is a really big hole under the waterline of the boat. So we asked the guy, the welder that's gonna weld our keel and rudders in place really soon, to do that also, because he is a professional boat builder for the past 25 years and we really trust his job. So this project is on hold, but not for too long. Really soon it's gonna be in place. It's exciting. At least it's ready. We just need to weld, and that's a really big step. But for now, that's it. We see you on the next one.
The train's coming.